My name is Andrea Manconi. I'm a senior scientist at Gamma Remote Sensing, and I will present you today work we've been doing to monitor displacements at a complex lenses scenario in the Swiss Alps. Of course, it's going to be very difficult to provide you a full set of information about the work we have been doing, so I decided to go quickly to the slides, and of course you can contact me if you have any specific questions on the techniques we used and also on the results. So as a background, everybody knows that we are living the golden age of SAR data, and especially for differential SAR interferometry, we have seen that this has been increasingly used also to monitor ground displacements. And we have seen also that in the last years there have been several programs at the national, country scale, and even the continental scales to monitor the ground deformation. But what is happening when we have to analyze a very local case scenario in the mountains? So for example, a complex landslide scenario. So and here we have focused on a very specific case study in Brienz in the Canton Graubünden in the Swiss Alps, where the entire slope is affected by deformation, and this deformation is characterized by spatial complexities and also temporal complexities. And we have also a risky condition because there is a village on top of this slope that might be affected by the deformation and by potential failure. So you see the velocities are quite high, in the order of a few centimeters a week, and also in some cases also up to centimeters per day. So this is of course very difficult to follow with standard interferometric data, especially with C-band like sentinels. So if you apply persistence counter interferometry in such an area, this is what you get as a result, is because the coherence is barely preserved due to this very high spatial deformation, and also because we are in an area that is not built, so we have only this village that is providing coherence over a long term. But you see that it's not very easy to identify and to really characterize the displacement of this area. That's the reason why we wanted to explore different possibilities and have a better representation of the spatial and temporal evolution of this slope in cooperation with the cantonal authorities and all the companies and also the community. So that we have applied several methodologies, including satellite-based radar interferometry and also ground-based campaigns, also including a new radar that was developed by Gamma in L-band, and this has been applied as a rail-based and also careboard in different meteorological conditions. Here you see a selection of the results. So just very quickly, what is possible to see is that there is a high spatial variability of the surface deformation while analyzing ascending and descending data, which was expected. It's also possible to see, comparing in different periods, that there is an increase up to 3 times of the deformation of 2015, which is also very important to know and was not possible to see with persistence counter interferometry. By using ground-based radar, we could also image areas that were in shadow or in layover from the satellites, also recognizing additional locations that are affected by deformation. And here you see also using different satellites like L-band radar data from ALOS, that it's possible to see deformation also in areas that are affected by vegetation. So, and last but not least, here is the example of the campaign that we've been doing with the cardboard radar at the L-band, and you see also the rail that is installed there. So we did several tests, and by combining this data with the other results that we had from the satellite, we could have a full set of the representation of the kinematic behavior of this landslide. Thank you very much for your attention, and if you have any questions, just please contact me. Thank you.